In our last video lecture, we're going, in the last video lecture? 1, 2, 3, 4, 5. Let us continue our discussion about kernel mapping. In our last video lecture, we discussed what is kernel map, and based on our discussion, it is another way of simplifying our equation, our Boolean equation, and it is a graphical method wherein it utilizes matrix, wherein we plot our product term or sum term in that matrix. And the matrix size is dependent on the number of variables given by the equation. So if it's 2 variable, it will be 2 by 2. If it's 3 variable, it's 2 by 4. And if it's 6 variable, it is 4 or 4 by 4. And also, we discussed what are the guidelines in using kernel mapping. So first, we need to start with the biggest group when we combine our product term or sum term. Okay, and the group should be group of 1, group of 2, group of 4, group of 8, or group of 16. So basically, it is based on power of 2 rule. And the shape of the grouping should be a square or a rectangle. And the number of cells, make it bigger. The number of cells should be bigger so that it means we're going to have lesser number of variables that will represent that group. And be sure to have fewer groups in using or in simplifying our equation using kernel map. Fewer groups means fewer terms in our equation. Okay? And we also discussed the different steps in using kernel map. So step 1, we need to determine the size of our kernel map. And again, it is based on the number of variables. And then we plot the the product term and sum term. Okay. And then we group it. We identify all essential prime implicant and non-essential prime implicant. And then after determining all the essential prime implicant, we get the corresponding equation of that group. And then just combine all essential prime implicant to get the sum of product or product of sum. Okay? So just a review, what is essential prime implicant and non-essential prime implicant? Let's define again what is an implicant and prime implicant. So if say implicant, these are product term or mean term on a given equation, which is the SOP. Or it could be a sum term or a max term in a given product of sum. So this implicant is actually, these are the inputs that we combine to give us a simplified equation. And again, when we combine implicants, it should be based on the power of 2 rule. Okay, implicant are sum term, product term of the given equation. Okay, and when we group the implicants, we could create a prime implicant. A prime implicant is basically the largest possible group of ones and zeros, okay, that we could form on the given kernel map. So in this example, the biggest group is 2. So it means we have 3 prime implicants, 1, 2, and 3. Okay, and the grouping should be, okay, the mean term should not, there should be at least one mean term or max term exclusive on that group, okay, or within that, exclusive on that size of group, okay, which is not part of a bigger group. So for example, if we have a group of 4, so other group of 1 which is not part of the group of 4 could be possible, could be considered as group of 2 or group of 1. Okay, so later I'm going to have examples how to determine the prime implicants based on a given kernel map. So after determining the prime implicant of the given kernel map, So we could derive the essential prime implicant. If say essential prime implicant, there is an exclusive one or zero on that group. So for example, initially we have three prime implicants, but based on our analysis, only two have exclusive one on its group. So first group, we have this one, which is not part of the other group. So this is exclusive to that group. So it is considered as essential prime implicant. Another group, which has an exclusive one. Therefore, this group is considered as essential prime implicant. But the third group, as you can see, there's no exclusive one. This one is part of this group, and this one is part of this group. Therefore, there's no exclusive. Therefore, this group is not considered as essential prime implicant. So if it's not essentially prime implicant, so what is it? It's redundant prime implicant, wherein again, there's no exclusive one or zero on that group. It is considered as redundant prime implicant. So if we have a redundant prime implicant in our grouping, remove it. It will not be part of the final equation or the final simplified equation. Okay. So aside from essential and redundant, we could form a selective prime implicant. If it's a selective prime implicant, there is options on how we're going to group or how we're going to determine the term to be included on our final equation. So for example, we have this one, okay? So we have essentials, one, exclusive one, another group which has an exclusive one. So we have this one, this product term or this mean term, which is not part of other group. And don't forget, we need to maximize the group size. Okay, so we need to group it to other one since it is adjacent to other one. So we have two options. So we could form group of two by grouping it with this mean term or group it with this mean term. Okay, so we have option how to group this one, this mean term, to form a group of two. So that is considered as a selective prime implicant because we don't need the two group, we only need one of these two group, okay, for our final result. Because if we're going to include the two, okay, both will not have an exclusive one. But if we're going to retain at least one of this prime implicant, we could have one exclusive midterm for that group. So if we have a selective prime implicant on our solution, it's up to you what to choose, which group will be included on your final answer. Okay, so in this example again, we have two selective prime implicant and only one should be included on your final answer. It could be either this group or this group. Okay, so that's selective prime implicant. Okay, just a review. Prime implicants are all product term based on the given sum of product or some term based on the given product of sum. And when we group the implicants, we could create a prime implicant, wherein, again, we need to start with the biggest group. And then later on, we're going to group the smaller group and be sure that at least one or at least one min term or max term is not part of the bigger group to be considered as prime implicant of the smaller group. And when we form a prime implicant, we could create an essential, which is part of the final answer, none, non-essential or redundant prime implicant, which will be removed, which will not be part of the equation, and selective prime implicant, wherein you're going to choose which of the given group will be part of the final answer. Okay?